Every time you load a web page, send a text, or stream a video, millions of data packets travel across the world in milliseconds. But how do different computers, applications, and hardware from hundreds of companies talk to each other without causing complete chaos? They use the OSI model, a 7-layer blueprint that breaks down networking into step-by-step rules. Think of it like sending an international package through a postal system. Let's break down all 7 layers from top to bottom. Layer 7, the application layer. This is the layer you actually interact with. It's not the app itself, but the protocols that let your app speak to the network, like HTTP for browsing websites, DNS for looking up web addresses, or SMTP for sending emails. This is you writing a letter and deciding to mail it. Layer 6, the presentation layer. Computers don't process data the same way, so Layer 6 acts as a translator. It handles data formatting, compression, and most importantly, encryption and decryption, like SSL and TLS for HTTPS. Translating your letter into a language the recipient understands, and placing it inside a locked box. Layer 5, the session layer. This layer creates, manages, and terminates the connection between two devices. It makes sure the connection stays open long enough to transfer data, but closes promptly when done, so resources aren't wasted. Like making a phone call, checking if the other person is listening, and saying goodbye before hanging up. Before moving down, the upper layers take your message and break it into smaller pieces, called segments. Now we enter the transport layers. Layer 4, the transport layer. This layer manages end-to-end communication and controls how data is delivered. TCP is reliable but slower. It guarantees every piece arrives in order, like registered mail with tracking. UDP is ultra-fast, but doesn't check if packets get lost. Layer 3, the network layer. This is where IP addresses live. Layer 3 attaches the source and destination IP addresses to your data, turning segments into packets. Routers use Layer 3 to find the absolute best path across the internet for your data to travel. Like writing the destination mailing address and zip code on your envelope. Layer 2, the data link layer. While Layer 3 gets packets between global networks, Layer 2 gets data between physical devices on the same local network, using MAC addresses, physical hardware IDs burned into your network card. Here, packets are wrapped into frames. Like the local mail truck delivering your letter directly to your house number. Layer 1, the physical layer. Finally, the frames are converted into raw bits, ones and zeros, and sent across a physical medium as electrical pulses, light flashes down fiber-optic cables, or radio waves via Wi-Fi. The actual roads, trucks, and planes moving physical mail. When the bits hit the destination server, the process runs in reverse. It unpacks from Layer 1 all the way back up to Layer 7, displaying the data on screen. Next time you open a website, remember, in a fraction of a second, your data just traveled through all 7 layers of the OSI model. If you found this clear, smash that like button and subscribe. Up next, we dive deep into TCP versus UDP.